Hello everyone, welcome to YourPedia Education. So, as you know, BSNL has released very good opportunity for the electronic CSC and many students from electrical and instrumentation, and they release notifications that they will take the exam for this senior position. See, basically, this is a very good opportunity for all of the electrical, electronic, CSA students, right, and instrumentation students, because if you see that notification, this time they are recruiting for a senior level, right? If you see that from the GATE exam, they are recruiting the JTO, Junior Telecom Officer, right? And after 10 years, that JTO will be promoted to that this senior position, and this time they are recruiting directly for that senior position. That is a very good position, right? If you want to prepare for that one, so their syllabus they have given on their website, you can check that. Inside that one, see what we are seeing, that there are several topics, right, which we are not covering in our engineering domain, right? So they are putting that type of syllabus. So what is the advantage of that one? The advantage of this syllabus is that the persons who are preparing from last 2 to 3 years, they are not having the advantage. Like some persons are preparing for the GATE exam, they are having the advantage on several exams. But in this exam, they are not having any advantage. So if you are preparing for that one, you are just to start your preparation, and other person which preparing last 2 to 3 years, and you both are standing at the same position, right? If you are putting effort from your side, you can easily crack that exam. So this is the factor why the this position cutoff will not going that much high, because this syllabus is very vast and several topics are covered, we have to cover here, right? So for that one, YourPedia will provide you, or already we are having the online classes for that one. See, in online classes, we have covered signal processing till now. Started, we are started the modulation and demodulation part, right? In parallel, we also covering the computer network. In parallel, the classes are going for optical fibers, project management also classes are going on. So if you want to prepare for that one, we are already, you can say we are already providing the classes for this module, for this exam, you can say like that, right? For this exam we already providing the classes, so you can join YourPedia classes if you want to prepare, because what you have to study and how much you have to study, it is very important. See, let us take an example that what is an antenna. He write in that portion that basics of antenna, only that thing he write, basics of antenna, VSWR, and several things he mentioned there. But in antenna, if you go for your graduation or masters, we are having a separate book, the antenna. That is not only, you can say, the single chapter, it is a separate book, right, for antenna. So how much we have to study, right, how much depth we have to cover, that is depend on that, that we will tell you that how much depth you have to study, right, and how much you have to study. We are not going to research on that one, right? And which type of question he can ask? He can ask only theoretical questions from these topics, because it is not possible to ask the questions from these topics that you have to solve the numerical. Why? Because you are having 180 minutes and 200 questions. So if you put the numericals, then how you can solve them in such a very less time of 180 minutes, right? 180 minutes, 200 question, that is a very big number, right? So basically he will going to ask you the basic questions. So that's why it is important that you have to study lot of the things, but not in depth. You have to prepare horizontally, not vertically, like we are preparing for GATE exam. But again, I'm saying that thing, that if you are preparing for GATE, you are not having any advantage. If you are preparing any other exam, you are not having advantage, because syllabus is totally different from any other exam. So today I'm going to discuss the some important topic, that is all about antennas, right? And what we have to study in this antenna, that is also totally different from your GATE antenna syllabus, right? Okay, So first thing, when we are talking about basic of antenna and EM communication, the first thing is come in your mind, that is electromagnetic wave, because your antenna is dealing with EM waves. Antenna is transmitting EM wave, it will receive EM wave. EM wave means electromagnetic wave. So basically, if I'm talking about an antenna, antenna is a device which can transmit the EM wave, which will receive at the input voltage and current. It will convert that voltage and current into EM wave. Whenever we are talking about a receiving antenna, when a EM wave strike that antenna, then that antenna will convert that EM wave into voltage and currents, right? So basically, electromagnetic wave, what is electromagnetic wave? Electromagnetic wave have two components. One is electric field, another one is magnetic field, right? Electric field and magnetic field. See, basically, when we are talking about the EM wave is a wave which is traveling in a particular direction. So if your EM wave is traveling in this direction, let us take EM wave is traveling in Z direction, then your electric field and magnetic field are perpendicular to that one. So no need to go in that much depth why they are perpendicular, because we are studying that thing in EM wave separately. That is not the part of here, right? You have to understand that you are having, if you are having electric field, you are having electric field on this axis, right? And you are having magnetic field on this axis, then your wave is always travel perpendicular to that one. That's why what we are saying, that EM wave is TEM wave. TEM, transverse electromagnetic wave. Transverse electromagnetic wave means what? That your direction of propagation, electric field and magnetic field, the three things are always perpendicular to each other. So that's why this is called as TEM wave, right? So always remember, whenever we are talking about EM wave, then electric field is perpendicular to your magnetic field, perpendicular to your direction of propagation. So three things. Direction of propagation means in which direction your EM wave is traveling, right? That direction of propagation is always perpendicular to electric field and magnetic field, right? And here another thing that is called as frequency, right? Frequency. The frequency is generally denoted by F. So there are two things which you are studied in your 12th class or your graduation. There are two things, that is frequency and wavelength. Another thing is what? That propagation velocity. Velocity means at which speed the EM wave is traveling in particular medium. So there is a relation that is called as F into lambda is equals to Vp. Vp means, or V means the propagation velocity. At which speed your EM wave will travel in a particular medium, that will be the multiplication of F into lambda. F into lambda. F means the frequency of that wave, lambda means wavelength of that particular wave. So basically the frequency will not change. The frequency will not change because the frequency is the property of source, not the medium. That's why whenever your EM wave travel in any medium, the frequency of EM wave will not change. Only propagation velocity and your wavelength of EM wave will change according to this relationship. Right, next we are coming to that most important part, that is electromagnetic spectrum. See, basically we are having the frequencies that are start from 0 hertz, right? And the frequencies are very high. The frequencies can be up to infinite. So for that purpose, that we are using that frequency spectrum for different uses. That what is happening, if you are thinking here from 0 to 50 hertz, so 0 frequency is generally for static electric and magnetic field. If you are having a permanent magnet, that will generate a magnetic field but that magnetic field will not time varying. The magnetic field is static. Static means its frequency is zero. So whenever we are talking about 0 hertz, that means we are talking about these two quantities: static electric field, DC current. Static electric field, DC current, or you can say magnetic field. Static magnetic field means what? Static magnetic field means permanent magnet which will generate a magnetic field that is having frequency as zero. After that, as you increase the frequency, next what we observe at 50 hertz, generally all our home appliances are working, because the supply voltage which is coming to your home, that is having a frequency of 50 hertz. So alternating electric and magnetic field, that is that is used for transmission purpose, that will have a frequency of 50 hertz. Then after that we are having a frequency range of 3 kilohertz to 300 gigahertz. That frequency range is called as radio frequency range. That is called as radio frequency range. As your frequency increases, see, initially the wavelength is high. On this one you are seeing the wave, and as the frequency increases, the wave are coming closer to each other. That means their wavelength is decreasing. So this frequency range, 3 kilohertz to 300 gigahertz, is generally used for radio frequency communication. In that one, this range of starting range is used for TV and radio broadcasting. After that, we will use for mobile phones, and after that, this range, certain part of our, you can say the uh, bigger part of this one will be used for microwave and satellite communication. Microwave and satellite communication. After that, we will have the certain frequency range that is used for visible sunlight. This range is used for visible. This range is used for ultraviolet. This is for X-ray, and this is for radioactive source. So this is the spectrum, how it will be divided into a certain range of frequency, and how that frequency range will be used for a particular purpose. That frequency range is used for particular purpose. That is the use of that one, right? Okay, next thing is what about the radio waves. So what is about the radio wave? The radio wave is the spectrum that is lying between 3 kilohertz to 300 gigahertz. This is the spectrum, or you can say this is the frequency range that is used for radio waves, that is called as radio wave, or you can say that is used for radio wave propagation. Means where we are using for TV broadcasting, mobile phone, right, satellite communication, that communication part, that is the radio part, you can say, that will be covering under the range of frequency from 3 kilohertz to 300 gigahertz, right? And this frequency range is called as radio wave. This frequency range is called as radio wave, right? That is widely used in our telecommunication. That is widely used in our telecommunication, right? So basically what is happening, if you are having, let us say we are using for radio transmission, we are using for television transmission, right? We are using a different spectrum for that one. So to prevent the overlapping, we will have a certain gap between them, that is called as guard band. That is called as guard band. And one more thing you have to remember, that okay, let us take an example. You are living in India, right? I'm living in India, and I'm using 900, let us take, not 900 megahertz for GSM purpose, right, in India. But in certain country, if they are having their own standards, they are using 900 for video transmission, then there will be a chance of overlapping. There will be a chance of overlapping. Or in a particular country, let's say currently I'm using 900 for video transmission, and some person also use that 900 for their practical their personal use, you can say. Then what happens? There is a chance that the spectrum of them is overlapping. So for that purpose, there is an international body which will decide that this frequency range is divided for this particular use. You can't use that frequency range for separate purpose. If they decide that one, that this frequency range is for GSM only, this frequency range is for TV transmission only, this frequency range is for FM broadcasting. As you see in FM broadcasting, they are having 88.5 megahertz to 108 megahertz. Right, that frequency range is decided that you can use only this frequency range for FM transmission, FM broadcasting. We can use only that range, not beyond that range for FM broadcasting. If you are assigning a channel, if you are going to start a particular radio station, FM radio station, then you have to use that spectrum only. Inside that spectrum, you will lease a particular part of that spectrum that I will transmit at this frequency. So that means to overcome the problem or interference, that international body that is called as International Telecommunication Union, that is decide that this range of frequency will be used for that particular purpose. So you can see here, this is wavelength on this axis, and at this axis we are having frequency. They decide that very low frequency will be used for this radio propagation, that is used for navigation, right? Navigation purpose, right? Then low frequency will be maritime radio navigation. Then medium frequency range will, you can go with this one here, this one here, this one here, that this medium frequency will be used for AM radio transmission, right? Shortwave radio, we are having high frequency. Then very high frequency for television and FM broadcasting, right? Like GSM, Wi-Fi and 4G will have ultra high frequency. Satellite communication, super high frequency. And then again radio astronomy satellite communication, that is having this frequency. So that frequency range is divided for a particular purpose, right? And they decide that you can use only this frequency for that particular range. So here extremely low frequency, that is having the range of 3 to 30 hertz, and it is also having the wavelength which is given here. So these are the frequency ranges. You can check here: super low, ultra low, very low, right? Low frequency, medium frequency. So what will be the range of these frequency? You should remember that thing. It's very important for this exam, right? Radio frequency range. Now again, the same thing is, what is an antenna? That is all about the spectrum, how we can use that spectrum for a particular use. Next thing is, what is an antenna, right? Antenna, what is an antenna? Antenna kya hai bhai? Right? So basically antenna is a device which can be used for two purposes: transmission and reception. That will be used for two purposes: transmission and reception, right? That mostly the antenna is a metallic structure. If you put an wire, that wire will also work like an antenna. But in practical cases, we are designing the antenna for several different uses, right? So antenna basically a metal element. It is a metallic element which can be used as a transmitter as well as a receiver, right? So this is the basic antenna structure. Inside this one, we are feeding with the coaxial cable. This coaxial cable will provide that antenna the voltage and current which you are generating. As these provided to this antenna is generally two wire structure, and it will radiate that voltage and current in the form of that, convert in the form of what? EM waves, right? So next thing is antenna pattern. So we have to study about the antenna pattern. See, basically when we are seeing that antenna pattern, oh, what is the antenna pattern? Basically antenna is specifically designed to radiate in a particular direction, right? This is an antenna pattern. Antenna pattern means what? This antenna is having, this is called as main lobe. Main lobe means what? If you are having antenna here, that is only radiated in a particular direction. That in this direction, it can radiate maximum. If you go in this direction, it will radiate less. In this direction, very less. In this direction, less. In this direction, it will radiate less. So this less radiated part is called as minor lobe. These less radiated part are called as minor lobes. So, and this backside lobe is called as back lobe, right? So, these, because this antenna is radiated in the front side here, so these are the minor lobe and these are called as, also known as side lobes. And at this position, what you are seeing, at this position, this antenna is radiating nothing. So, this is called as null. So, antenna have a main lobe, side lobe, or you can say the minor lobes. Minor lobe means whose width is very less and it is radiating in a particular direction, that is called as main lobe. Now, after this, see, inside this main lobe, we generally define the half power beam width. At this particular position, the antenna is radiating the maximum power. So basically, half power beam width what? Whenever your antenna is radiating at this position, this antenna is radiate the half of the maximum power, right? At this position, this antenna is radiate the half of the maximum power. So if it is radiating half of the maximum power at this particular position, and you will match that with the antenna, where the antenna is lying. So this angle from here to here, this angle is known as half power beam width. This angle is known as half power beam width. So this is half power beam width. That is really, or 3 dB point also it is known as. See, if you are attend the lecture of DSP, I already told you that thing in DSP, that how we convert into dBs, the voltage and power, you convert them into dBs. So if you are going for half power, then that power, if you convert that power into dB, that will represent the 3 dB. So these are points where the power is half is also known as 3 dB points. So these are the 3 dB points, and this angle is known as half power beam width. Again, next thing is an antenna gain, right? Okay. So basically, when we are talking about the antenna generally radiate in all directions. Generally radiates in all directions, but in a particular direction, it is radiating maximum energy. There is a concept of omnidirectional antenna as well. There is a concept of omnidirectional antenna as well. The omnidirectional antenna is antenna, or you can say isotropic radiator, right? Isotropic radiator means what? An antenna which will radiate in all directions, equally in all directions, right? That is called as isotropic radiator, right? But it is an ideal condition, right? It is an ideal condition. So if I'm talking about omnidirectional antenna or isotropic radiator, both are the same thing. Isotropic radiator will also radiate in all direction, but practically it is not possible that a particular antenna can radiate in all direction. In 3D space, it will radiate in a particular direction. That's why you are seeing on the towers, we are seeing what? There are several antennas are connected in different directions. Why? Because one antenna can radiate in a particular direction, right? There is a term, I'm again repeating, there is a term omnidirectional antenna. Omnidirectional antenna is antenna which can radiate only in a particular direction, which can radiate in a particular omnidirectional antenna means what? Which can radiate in all direction. Or isotropic radiator is the same name. The name of the isotropic radiator and the, you can say, omnidirectional antenna, both are same. One more thing, so we are taking that reference that omnidirectional antenna is radiating in a all direction with equally, so we are taking that one as a reference, and And we are talking about antenna gain, right? We are talking about antenna gain. So if your omnidirectional antenna is radiating in all directions, so we will take that reference and we will find that this antenna is radiating in that particular direction. So how much is the gain? See, whenever we are talking about the antenna gain means what? You are having the antenna, right? I am having the antenna and we are input the power to that antenna, we are inputting the power to that antenna. So this antenna will radiate that power in a particular direction. So we will find that how much power it is radiating, right? So gain of an antenna is defined as what? How much power it is radiating. So radiated power divided by what? Radiated power divided by input power. So if I'm talking about the gain of an antenna, if I'm talking about the gain of an antenna, see, the gain, generally gain is defined as what? That how much power it is radiating, because it is radiating in a particular direction. So that's why the gain is all that. The gain is the gain of antenna is the property of direction, that in this direction how much gain, in this direction how much gain. That's a different concept, so we are not going in that much depth of that one. So we are talking only about the gain of the antenna. The gain of the antenna is what? The power radiated by that antenna divided by how much power you will provide at the input of that one, right? That is called as gain of an antenna. Next is impedance of an antenna. Impedance will also play a very crucial role about the antenna. See, if you studied the maximum power transfer theorem, the maximum power will be transferred to the load whenever it is having the RTH will be equals to your load resistance, right? Because I'm telling that thing for all of the student, but that is not the correct concept here. Here the concept is VSWR, or you can say the reflection, right? Because whenever you put a transmission line to that antenna which will feed that antenna, like this is your antenna, what you are seeing here. Yeah, this is a cable which will feed this antenna. This is your antenna, right? This is your antenna, and this cable will feed this antenna. So whenever power strikes to this antenna, there is a term that is called as reflection, right? There is called as reflection. So when this power is inserted to that antenna, so some amount of power this antenna will reflect back, and that's why there is a term is called as reflection coefficient. Reflection coefficient means what? When you feed this antenna via coaxial cable, then reflection coefficient is ZL minus Z naught divided by ZL plus Z naught, right? ZL means what? The load means this antenna impedance, and Z naught means what? The characteristic impedance of this transmission line. So this is called as reflection coefficient, that if the power is incident, how much power it will be reflected back to that coaxial cable, right? Because you are having coaxial cable, when the power strikes, not always the all power will transmit it to the antenna. Some power will be reflected back by the antenna in the same transmission line. So to avoid that condition, that our maximum power or total power or total voltage will be transmitted to this antenna, for that purpose what we are having, we have to match this with, we have to put this reflection coefficient equals to 0, because if reflection coefficient is 0, it means your reflected voltage or reflected power is going to be 0. It means your ZL minus Z naught should be 0, and ZL is equals to Z naught. That's why this matching is most important, that if you are having a coaxial cable of 50 ohm, then your antenna impedance should also be 50 ohm, should also be 50 ohm. That's why we generally see that antenna impedance should be 50 ohm and cable impedance will also be 50 ohm here, right? Again, that condition from that reflection coefficient, when some voltage is reflected back, let us say this is your load here, this is your antenna, and your input wave is like this. Oh, let's make it different. Yeah, this input wave is like this to this antenna, then after incident to that antenna, the voltage is reflected back like this, right? This blue one is reflected voltage, red one is incident voltage to this antenna, right? This antenna. So what is happening at that particular time when it will reflect back some voltage? So there is a standing wave formation here like this. There will be a wave which is called as standing wave, right? There is a waveform that is called as standing wave. Now if there is a standing wave formation, for standing wave we will define the standing wave voltage standing wave ratio, that is called as VSWR, voltage standing wave ratio. And that VSWR value is that, because you are saying there is a maximum difference in between these two, so this is called maximum voltage. When there is a minimum difference, that is called as minimum voltage. So what is VSWR? That will be the maximum voltage divided by minimum voltage. And if you solve it completely, no need to go in that much depth. So its values of VSWR is going to be 1 plus mode of reflection coefficient divided by 1 minus mode of reflection coefficient. Reflection coefficient I already discussed in the previous slide, right? So VSWR is 1 plus reflection coefficient, 1 minus reflection coefficient. So if I'm going for ideal case, whenever your antenna is completely matched with your transmission line, then magnitude of reflection coefficient is 0 and VSWR is 1. So VSWR should be 1. VSWR should be 1 for your antenna, ideal case, right? So whenever we are having a higher VSWR, because if you go for VSWR minimum value, that minimum value of the VSWR is 1 and maximum value can be infinite whenever your mode of reflection coefficient is going to be 1. So what it VSWR tells you, that how much power is reflected, that how much amount of mismatching is happening at your load side, right? That will be told by this VSWR. Why we are studying? Because VSWR can easily be measured by a VSWR meter. So generally we are having VSWR meter when you are working on any site of BSNL or anywhere where you're dealing with the transmission line or antenna, then there is a VSWR meter. So you should aware about that VSWR meter will tell you that voltage standing wave ratio is how much. If your VSWR is very high, it means there is a mismatching, and we have to cover that mismatching by using that impedance matching techniques, right? No need to go in that impedance matching techniques, but you have to study what is VSWR and why it is important. So VSWR will tells you that higher the VSWR, the greater is the mismatching in that one. So this is the basic concept of antenna, and it is having more slides which we will discuss in the next lecture. But again saying, this is very important because you no need to study all about the antenna, what is directional gain, derivative gain, directivity, right? Hertzian dipole, or no, that is not required for this exam. Only these things are required for this exam, which I discussed here, and rest all the things are available here, that omnidirectional antenna, how their patterns, right? And these things, and these are we are going to discuss in next lecture, that directional antenna, right? And fire arrays, antenna panels, how they look like whenever we will use them on the towers, antenna systems. These are the part, right? These are the part of this one. So basically, if you want to prepare for this exam, you can join YourPedia, where we are having the live classes, and we are currently we are doing the modulation, demodulation, and optical fiber communication parallelly going on. One more, I think 50% of the syllabus of your computer network is already covered, project management is already covered, and YourPedia is also going to launch the book of this one, right, in which we are providing lots of questions for your practice. So I think this information will help you. Thank you.